Let's solve a calculus problem where we need to find points on a curve where the tangent line has a slope of 1. The curve is given by y equals x cubed minus x squared minus 7x plus 6. To solve this, we'll follow these steps. First, find the derivative to get the slope function. Then, set the slope equal to 1 and solve for x. Finally, find the y-coordinates for those x values. Let's start by finding the derivative. Using the power rule, the derivative dy dx equals 3x squared minus 2x minus 7. Since we want points where the slope equals 1, let's set this equal to 1. This gives us 3x squared minus 2x minus 7 equals 1. Subtracting 1 from both sides, we get 3x squared minus 2x minus 8 equals 0. Let's solve this quadratic equation. First, we can rewrite it as 3x squared minus 6x plus 4x minus 8 equals 0. Factoring by grouping, we get 3x times x minus 2 plus 4 times x minus 2 equals 0. This simplifies to x minus 2 times 3x plus 4 equals 0. From this factor form, we can see that x equals 2 or x equals negative 4/3 are our solutions. Now, let's find the y-coordinates by plugging these x values back into our original equation. For x equals 2, we get y equals 2 cubed minus 2 squared minus 7 times 2 plus 6, which simplifies to negative 4. For x equals negative 4/3, after substituting and simplifying, we get y equals 302 over 27. Let's visualize this on a graph. Here's our curve y equals x cubed minus x squared minus 7x plus 6. And here are our 2 points where the tangent lines have a slope of 1. Let's draw these tangent lines to verify they indeed have a slope of 1. In conclusion, we found 2 points where the tangent line has a slope of 1, the point 2, negative 4, and the point negative 4/3, 302 over 27. We found these points by using calculus to find where the derivative equals 1, and then finding the corresponding y-coordinates.